Hi students, now we are going to derive the values of Cp, Cv and gamma for a linear triatomic molecule at high temperature. Just now, before this we have derived for a diatomic molecule. Diatomic molecule has only two atoms. If you join them, its shape is like a dumbbell along a straight line. It is linear in shape. Now imagine if three atoms are joined along the same line, similar to dumbbell structure. So it is also called a linear triatomic molecule. And for example, we can take it as carbon dioxide or carbon disulfide at a higher temperature. So it is similar or the same as that we have derived for a diatomic linear molecule at a higher temperature. So we start with the average kinetic energy per degree of freedom, that is half kT, and the number of degrees of freedom for a triatomic gas molecule at a higher temperature is 7. So the average kinetic energy per molecule is 7 times half kT, that is 7 by 2 kT. And hence the average kinetic energy for 1 mole, epsilon is equal to Avogadro number into, this is the kinetic energy per molecule. The product of Na into K is equal to the universal gas constant R. Therefore, epsilon is equal to 7 by 2 R into T. This is our usual first step. Then after that, the same steps to be followed. We have to determine the specific heat capacity at constant volume Cv. That is the differentiation of this internal energy with respect to the temperature. So du by dt is equal to d by dt of 7 by 2 RT. Here T is the variable, 7 by 2 is a constant, and d by dt of T is equal to 1. Therefore, Cv is equal to 7 by 2 times R. Same like that of a diatomic molecule at a high temperature. And from Mayer's relation, Cp minus Cv equal to R. So Cp equal to Cv plus R. So if you add 7 by 2 R plus R, we get 9 by 2 R. Therefore, the value of Cp equal to 9 by 2 R becomes the equation 3. So from Cp and Cv, how to determine the adiabatic exponent gamma? It is the ratio of Cp and Cv. So it is 9 by 2 R divided by 7 by 2 R, which is equal to 9 by 7 equal to 1.28. So the value of gamma is the same for a triatomic molecule at a higher temperature as well as a diatomic molecule at the high temperature, provided if the triatomic molecule's shape is linear, if it is a linear molecule. So for it also the value of gamma equal to 1.28, same as that of a diatomic molecule at high temperature. I hope you must have understood well. Fine.